Okay, so for today's deep dive, we're going to unpack something that looks a little intimidating on the page.
It really does.
We're looking at modular congruence, and our source gives us this very specific puzzle to solve. Find the least value of x for 4x is congruent to 7 modulo 9.
Right. And what's fascinating here is how, we can immediately translate that.
It's not as scary as it looks.
Not at all. That whole equation, it's basically just asking you what's the smallest positive number you can use for x.
Okay.
So that when you multiply it by 4 and then you divide that result by 9.
Which is our modulus, our cycle.
Exactly. You get a remainder of exactly 7. That's it. That's the whole question.
It's kind of like clock arithmetic, right? The clock just has 9 hours on it.
Precisely. And we're trying to land on 7. Now, a mathematician might look at that and, immediately start looking for a multiplicative inverse.
The big formulaic approach.
Yeah, and that's what you'd need if the numbers were huge. Like if the modulus was, say, 1,000 or something. But this is where the source material is, I think, really clever.
Yeah.
Because the modulus 9, it's so small.
It's manageable.
And 4 and 9 don't share any factors. So they suggest we just skip all that heavy lifting.
They call it direct substitution.
Which is, it's really just a smart way of saying plug in numbers until it works.
The path of least resistance. So let's test it.
Yeah.
The whole idea is to find the smallest positive integer for x.
Right. So we start at 1. We just, ran the trials. For x equals 1.
4 times 1 is just 4.
And the remainder, when you divide 4 by 9, is, well, it's 4.
So not 7. That's a no.
Not 7. So we try x equals 2. 4 times 2 is 8.
Okay, getting closer. The remainder there is 8.
Close, but still no cigar. So
Yeah.
next is x equals 3. 4 times 3 is 12.
And if you divide 12 by 9, you get a remainder of 3.
So we miss it again.
And this is where it gets really interesting, because the source was kind of betting on this being a quick process.
And it is. Let's just zoom in on that next number, x equals 4.
So we plug that in. 4 times 4 is 16.
And that's our aha moment right there.
Because you take 16, you apply our modulus of 9.
9 goes into 16 one time.
With a remainder of 7.
Exactly 7. It satisfies the equation perfectly. That substitution strategy, it just paid off.
So what does this all mean? We've solved this complex-looking thing with, just basic multiplication.
The big insight here, I think, is that with small numbers like these, the actual search for a solution it's incredibly small.
You don't need the complicated tools.
You don't. The source chose this method because knowing when to turn off the theorems and just count, that's the real shortcut.
So we affirmed it. X equals 4 is the least value.
The smallest whole number that works.
And that wraps up the problem. But we did mention this is cyclical.
It is. Since we're working modulo 9, the answers have to repeat.
So a final thought for you to mull over. If 4 is the least positive value for x,
what would the next positive integer be that also solves the equation? Think about that cycle length of 9. Where does that next solution have to fall? Something to chew on.